Hello! This video is a continuation of the limiting reactant video in which we found limiting reactant being N2 in our 3H2 plus 1N2 reacts form to an H3 equation. What we're now going to do is answer the question in question 5, which is how many grams of NH3 would be produced. We're then going to look at how many grams of excess reactant would remain. Alright, so you first have to find your limiting reactant, which we did in that previous video. Once you found your limiting reactant, we found it to be 100 grams of N2, which is converted to 3.57 moles of N2. We're then going to take 3.57 moles of N2, which I just wrote down there, and we're going to convert it to our product. We have 2 moles of NH3 for every 1 mole of N2. So we're going to write that down. 2 moles of NH3 for every 1 mole of N2. 2 over 1. 3.57 times it by 2. 3.57 times it by 2 gives us 7.14. Moles of NH3, but then the actual question is asking for how many grams. So we're going to take our moles of NH3, convert it to grams, finding molar mass, nitrogen, the atomic mass is 14 on the periodic table, hydrogen is 1, but there's 3 of them, you add it all together, you get 17. So 7.14 times 17 gives us 121.38. grams of NH3, but we gotta take it back to correct sig figs, which is 100, which is really broad. Why don't we just say that this was 100.0, meaning 4 sig figs? So this was 100.0. That would mean we need 1, 2, 3, 4. This would be 121.4 grams of NH3. Would be our final answer. Alright. Going to find the excess reactant that's left over. You might have a question that says how many moles of excess reactant would be left over after the reaction. First, what you have to do is find out how many moles of excess reactant are used up. So in that case, you're going to find some space over here, your limiting reactant, which was 3.57 moles of N2, and you're going to do a mole mole ratio comparing it to excess reactant to limiting reactant. Your excess reactant was H2, your limiting reactant was N2. Go back to your actual equation, you've got 3 moles of H2 for every 1 mole of N2. So it's a 3 over 1 ratio. So I'm going to take my calculator that I bring to my chemistry class every single day. 3.57 times 3 divided by 1 is 10.71. Alright, so 10.71 moles of H2 is how much excess reactant is used up, providing that 3.75 moles of N2 is totally consumed, which it is because it's the limiting reactant. Alright, going back, I had 100 grams of H2 that I converted to 50 moles. So I have 50 moles of this excess reactant, 50 moles of H2, but 10.71 moles was used up. So basically 50 minus 10.71, 50 minus 10.71 gives me 39.29. 39.29 moles of H2 is how much excess reactant is left over. Alright, but it doesn't end there because we go back to question. The next part is how many grams of excess would remain. So we found out how many moles would remain. Now we just got to convert that to grams. So multiply it by a conversion factor, grams of H2 over 1 mole. Atomic mass of hydrogen is 1, but there's 2 of them in that H2, so it's 2 grams. 39.29 times 2 is 78.58. that is my final answer. Going back, we've got 100.0 grams is 4 sig figs. Final answer, 78.58 is 4 sig figs. And that is how you use limiting reactants and stoichiometry to find your answer.